Hello and welcome to another video. Today we're going to be working on split linked list into parts. And so you're given a linked list and an integer k. You want to split it into k consecutive linked list parts. And you want to split it so it's as equal as possible. And if there is nothing, then you want to return nothing. For this first example, k is 5. So essentially, since you only have 3 elements, you just want to return a list of 3 or 5 parts, and it also shows that the parts occurring earlier should have a size greater than or equal to the parts later. So you want to have 1 in the first part, 2 in the second part, 3 in the third part, and then 2 empty nodes because you need 5 parts and you only have 3. Okay, so for the second one, you have 3 parts and you have 10 nodes. And so now, if you think about it, it should be, there are 10 nodes, so each part should have at least 3, but the first part should have 4 because there's 1 extra node. So it's going to be split like this, and this, and this. Okay. And we want to think about how we can do this efficiently. And this is very similar to the problem where you are splitting a code block into text. That was like a hard problem from a few weeks ago. And so we're going to go over that, but we are going to go over how we do that and like what the best thing to do would be. So let's do that. So let's just write out a problem, for example, and we're just going to have nodes 1 through whatever, just to make it simple. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll do 11. And let's say we want to split that into 3 parts, or yeah, let's do 3 parts. So how would we do this? Well, the first thing you need to do is you need to actually get the length of your list, because you need to know like how many nodes should be in each part, right? So the first thing we are going to do is we're just going to go through this list, obviously with like a curve pointer or whatever you want, and we're going to figure out how many nodes are in the list. So once we get that, so we get list length equals 11. So now we need to figure out like how many, so we know we need 3 buckets, but how many nodes should each bucket have, right? So the way we're going to actually do this is we are going to say how many nodes should the bucket have as a minimum, and then we're just going to count how many extra nodes there are. And the way we're going to do that is we're going to say for the minimum, let's call that m, it's going to be 11 lower divide 3, which is going to be 3, right? So each node, each bucket should have at least 3 nodes, but obviously there will be 2 nodes with 4 buckets, right? So it's going to go 4, 4, 3. And so we're also going to have one more variable. So this minimum is going to have 3, but we're also going to have an extra variable that will have how many extra nodes do we have, and how do we calculate that? Well, that's also pretty straightforward, just 11 mod 3, right? This is how many extra nodes you have, and we're going to have 2 here. So now that we know the length and we know how many nodes go in each bucket, right, for our output, now we just need to figure out how do we actually split this correctly. And that part is also pretty straightforward. Let's say we have this result array, and it'll just be some array. And essentially we're going to start here, and we're going to need to figure out for every single bucket how many nodes does it need to have. So what we're going to say is, okay, for every bucket, let's just say we start at the beginning. So let's call this the head, right? And then we're going to have a current node that's also going to start here, and a previous that will be over here. So previous will be out of bounds. And so for every bucket, we need to figure out how many nodes it has. So what we're simply going to do is we're going to say, okay, let's take the minimum, and if there's an extra one, let's just take one, right? Because we want the early buckets to have the extra nodes, and how many should we take? We should just take 1. Right? Because we want the difference to be 1 at the most. So if we take more than 1, then there's going to be a bigger difference. So essentially, we're going to say, okay, for this first bucket, we have 3, and we have 2 extra nodes. So instead of taking 3, let's take 4, because we have an extra one, so we might as well use it. So the way we're going to do this is we are essentially going to move our current out 4 nodes. So it's going to go 1, 2, 3, 4, right? So our current is going to go over here. And it's pretty straightforward. You just do cur equals cur.next. And this previous should always be 1 node behind the current. And that's also really easy, right? You just say like previous equals current, and then you move the current up afterwards, right? So previous would be here, then you move the current up, and then so on. So the previous would be here, and so the previous is always 1 node behind the current. So this is what we want it to look like now after this first iteration. And now our head is still here. And now, if you think about it, we need to make a cut here, and we need to put this part of the list into the list. So, pretty straightforward. We're just going to say previous.next equals none, right? So now this is going to be like this, right? And now all we need to do is we can just put the head into the result. So we can put the head into there, and that will be that linked list, right? So this part right here will go in here if we just put the head in there. And so we are going to do that, and now we need to update the head to be over here, which is pretty straightforward. We'll just say head equals current. And even though this previous is over here, like I said, at every iteration for current, we're going to say previous equals current, and then cur equals next. So this previous will move later on. So now for the second bucket, and by the way, you notice that we also used one of our extra nodes. Now we have one more extra node, or one less extra node. Now we only have one. Now for the second bucket, we're going to do the same thing. We're going to say, okay, we need 3 nodes. Do we have any extra nodes? Yes, we do. So we're going to take that. So once again, we're moving up 4 nodes. So our current is going to move up 4 nodes. So 1, 2, 3, 4. Once again, pretty straightforward code for that to move it up 4 nodes. Previous should always be 1 node behind. Also pretty straightforward, right? You literally say previous equals current, and then current equals cur.next, which will give you that. So our current's over here. Our head is over here. And now, once again, we need to make a chop here. Well, we have this previous node, so we can make that chop. Pretty straightforward. And now, once again, we need to put the head in this list. So now this part here will also go into this array at the next index, right? So first we put in 1, that points to 2, 3, 4. Then we put in 5, that points over here. Now we update our head. So let's update the head to be over here again. And now we do the same thing. So we just say, okay, let's do this again. How many nodes? So remember, we use that node. So now we have no extra nodes. And now we move this current up 3 nodes. So 1, 2, 3, and then we are out of bounds. And we're never going to move the current up more than 1 node out of bounds. So current is going to be over here. Previous is going to be 1 node behind. Let's get rid of that. And once again, we are going to say previous.next equals null, which it already is. And now we simply put this head into the next part of the list. And so that's how we break it down and we can finally return. So let's write down our steps. And we are missing one little check we can do as well. So steps, 1, get length of list. 2, get min nodes in each bucket. 3, get extra node count. Now, for every iteration, and we just keep doing this until k is 0, right? So here we did 3 iterations, so k is 0. So for every iteration of k until k is 0, what do we need to do? Well, we need to move cur up min amount, and one more if we have extra nodes. Then have previous behind cur. Then we need to make previous.next equals none to make that chop. And then finally put the current head, let's move this down a little bit, put the current head into the list, and then update the head to equal cur. And so there is one other, like this will work, but there is one other thing, and that's this case here. So this case here, your current is going to be out of bounds like really fast, right? So if you think about it, we can just do a quick little run here. So if we have the head here and we have the current, I'm just going to make all these variables here for now just to make it faster. So we're going to have the head, the current, and the previous. And here k is 5. And then how many nodes should go in each bucket? There should actually be 0 because it's 3 mod 5. And then there are 3 extra nodes. So essentially, we would say, okay, for this first one, let's move it up 1 because we have 1 node. So the current will be here, the previous will be here. We'll get rid of those. And then this will be 2. And then you're going to get rid of this, put the 1 in, right? And you keep doing that. But after 3 iterations, what's going to happen is your current is actually going to be out of bounds. So when you're on these last 2 iterations, your current's out of bounds. So we can just check before all this, when we do this loop, for every iteration here, we can just check if the current's out of bounds, then let's just put in an empty node, right? We don't need to do this whole like next situation. So that's our other check that we can do right before is we can just say, okay, if the current is out of bounds, we'll just put in an empty node. We don't need to like do this previous and head and all this stuff because the current's already out of bounds. So that should save us some time. But that's essentially it. We get the list, you get the minimum number of nodes in each bucket, you get your extra nodes, and then for every iteration, you simply just move the current up the right amount of times. And if there is an extra node, you always want to take it because you want to have your nodes in the beginning be bigger than the nodes at the end, right? The parts should be in order, and parts occurring earlier should always have a size greater or equal to parts later. So if there's an extra node, we just take that extra node, then that would ensure of that. Then we simply have the previous one node behind the current, and then we break wherever the previous is, and we put in wherever the head is into the result, and we update the head to be the current, and that's going to be like our new list that we're looking through. And we keep doing that until k is 0. And if current is out of bounds, then we can just say, let's just put in none because there's essentially nothing to iterate also until k is 0. Okay, and now we have enough to actually be coding, and this is going to be an in-place solution. Pretty much like every other linked list problem, is almost all of them should be in place ideally. So you just need to be good at using pointers and do it that way. So now let's code it up. So we are going to say, first we're going to get the length of the list, right? That's the first part. So we're going to say current equals head, elements equals 0, and elements will be the length of the list, result. So we can initialize that. So we can just say while cur elements equals 1, just a normal get length of a list, right? Cur equals cur.next. So that'll give us the length. Now we need to calculate the minimum elements we need. So we'll call that nodes per part. So this is going to be the minimum nodes we need. So that's going to be elements over k. And then the extra elements will be elements mod k. Right. Okay. Now we are going to do our actual loop through k elements. So like I said, we start at cur equals the first node, previous equals none, and previous should be 1 node behind cur. So we can say while k. So remember, if cur is already out of bounds, we can just keep appending none. So we could say if not cur, let's just res append none, right? We don't need to keep iterating because we're already out of bounds. There's nothing left. So that would be like for that first example where, you know, you have 3 elements and you need 5 buckets. You're going to be out of bounds after 3 elements. So then we have an else case. So we can say while nodes, pretty much, because essentially you want to be looping while you actually have nodes to go through. And you are always going to have nodes to go through, right? Because otherwise cur would be out of bounds. So essentially, we need to figure out like how many nodes we actually go through. And oh yeah, I forgot one more thing. So there needs to be another, we actually need to get these nodes, right? So nodes is going to be nodes per part. So essentially if there's like 3 nodes per part, we need to loop 3 times. So that's pretty much what we're doing here. You can just do a for loop as well if you want to. That would be totally fine. I guess we could do that, right? So we can just say like, yeah, let's just do it that way. Make it a little bit cleaner. So we could say like if, or not if, for, we don't need this value, in range nodes per part. So we're just going to essentially loop, nodes per part times to move the current up that many times. So we can say, well, if that's the case, previous equals cur equals cur.next. And that's pretty much all we need to do there. And then we need to check, like after we move the cur nodes per part, which is the minimum we need to move, we need to check if there are extra any elements, and if there are, then we need to move it 1 more, right? So if extra elements, then we need to move it 1 more time. So this is all the same. And we need to subtract 1 from extra elements because we just used 1. So now finally, like previous should be right before cur, so we need to make that chop. So we can say prev.next equals none. Then we need to res append head, because the head is going to be the head of the current chunk of the list that we need. And then we need to update the head to be cur. And then finally, at the end of this loop, we need to do k minus equals 1 because we need to loop k times. And finally, at the end, we need to return the result. give that a go. Let's see, so nodes per part. Probably call this something different. Pair. Part. Okay. And looks like we have something that works. And you can see it's reasonably efficient. So let's go through the time and space complexity for this solution. So for the time and space, we are essentially getting the length of the list, right, which is O of n. So this part is O of n. And then we are looping through the entire list one more time. But once we're out of bounds, we're not really doing anything, right? Like for these k, it's going to be, we're essentially not doing anything. Well, we are doing a little bit, but we are appending for k. So we do have to take k into account because let's say k is like, I guess k is really small here, so it's not that bad. But let's say k is 50 and you had 3 nodes, you would still iterate 50 times essentially. So I would say it would be somewhere along the lines of n, the length of the list, plus k. It would actually be, would it be that? I don't think. I mean, it's either n plus k or maximum of n and k, which I think I'm just going to say n plus k. I think they're around the same anyway. So either n plus k or maximum of n and k. For example, if n is 1,000 and k is like -1, you are still technically doing this operation for every k, or even if you had nothing here. So I guess it would be something like n plus k, even though for the most part, n is going to be way bigger than k, technically. But yeah. And for the space, it's going to be, so let's see. It's going to be, we didn't make any extra like things, right? So we made like these variables, but we didn't make any extra actual nodes, I believe. We did make some variables, but we didn't make any extra nodes, and then our result shouldn't count. This should be O of 1 space. So yeah, I think that's it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.